Hello students, in our first chapter of algebra, we have studied concept of sets, methods of writing sets, and also we have solved some examples from practice set 1.1. Now, we are going to study the types of sets. Now, we will study the types of sets by considering the examples one by one. Now, see here this example. A is the set of even prime numbers. You know that there is only one even prime number. That prime number is 2. So, this set can be written as like this. That means in set A there is only one element, and such type of set is known as singleton set. The first type of the set is singleton set. The definition is a set consisting of a single element is called a singleton set. This is the example. This is one example of singleton set. Now, we will have another type. Now, this is one more example. B is a set of all x such that x is natural number between 2 and 3. Now, this set is written in rule method. We will try to write this set in listing method. The name of set is B. So, how to write natural numbers between 2 and 3. See here. Natural numbers are 1, 2, 3, 4, and so on. These are natural numbers. Now see here. 2 and 3. Between 2 and 3, is there any natural number? No. There is no any natural number between 2 and 3. Therefore, in this set, there is no element, and such set is known as empty set or null set. This is second type of the set, empty set. And that empty set is represented by this symbol or by this symbol. This symbol is known as phi. This symbol is used to represent the empty set, or you can write empty set using this symbol also. The definition of empty set is if there is not a single element in the set which satisfies the given condition, then it is called a null set or an empty set. And that is represented by this symbol or this symbol. Next example, C. C is a set of all P such that P is a number from 1 to 22 divisible by 4. So numbers which are divisible by 4 from 1 to 22 are. So you can write this set by listing method like this: 4, 8, 12, 16, 20. And the next number divisible by 4 is 24, but the 24 is greater than 22. So the elements are only up to 20. These are the elements divisible by 4. The numbers divisible by 4 from 1 to 22. Now in this set, elements are countable and these numbers are these elements are limited. You can tell the last element and first element also. That means here elements are limited, these are countable, and such type of set is known as finite set. This is the third type. Finite set. The definition: if set is null set or number of elements are limited and countable, then it is called finite set. So this is an example of finite set. Now, so next example is a set of natural numbers. And elements are 1, 2, 3, 4, 5, 6 and so on. So these numbers are infinite. We cannot tell the last element here. So such type of set is known as infinite set. This is another type of set. Infinite set. The definition is: if number of elements in a set is unlimited and uncountable, then the set is called infinite set. This is the example of infinite set. Now we will study equal sets. For that, here we have taken one example here. Here are two sets. The set first is A. A is a set of all x such that x is a letter of the word listen. And another set is B. B is a set of all y such that y is a letter of the word silent. Now we will write these two sets by listing method. See here. Letters from the word listen. So that means the elements are L, I, S, T, E, N. These are the elements of set A. Now we will write the elements of set B. Letters of the word silent. That means S, I, L, E, and D. Now see here, in both the sets A and B, elements are same. All elements of the set A are in set B also. Only order is changed, but elements are same. And such type of sets are called equal sets. And in symbolically, they are written as A is equal to B. This is the example of equal sets. That means two sets A and B are said to be equal if every element of set A is in set B and every element of set B is in set A. And then set A and B are called equal sets, and symbolically it is written as A is equal to B. Now the second example of equal sets. Set A. A is the set of all x such that x is equal to 2n. n is an element of n. That means this n, capital N, is set of natural numbers. And 0 is less than x is less than or equal to 10. Now, if you write this set A by listing method, that means here the elements are 2n. That means greater than 0 and less than or equal to 10. So the first element will be 2. All elements are in the multiple of 2 here. 4, 6, 8, 10. These are the elements of set A. Now set B. B is the set of all y such that y is an even number. 1 is less than or equal to y. 1 is less than or equal to y is less than or equal to 10. Now here, that means even numbers which are greater than or equal to 1 or and less than or equal to 10. Here will be the same elements. That means if you observe the elements of A and B, in both the sets, elements are same. All elements of the set A are the elements of set B. And all elements of set B are elements of set A. Therefore, set A and set B are equal sets. These are equal sets. That means A is equal to B. Now see here another one example here. Two sets are here. Set C. The elements are 1, 3, 5, 7. And set D. The elements are 2, 3, 5, 7. Now see here. 1 is the element of set C. 1 is an element of set C. But 1 is not element of set D. 1 is in set C, but it is not in set D. Now 2 is element of set D. but 2 is not element of set C. C. Therefore, the elements of both the sets are not same. So, therefore, set C and D are not equal sets. These are not equal set, and we can write like this: C is not equal to D. So, these are the types of set. Now in next pair we will solve examples from practice set 1.1.